Before we dive into our sensory and perceptual systems, let's talk about what exactly distinguishes sensation and perception. So, what is the difference between sensation and perception? Well, on a more global level, sensation involves physiological processing, while perception involves the processing of meaning. More specifically, sensation is the reception of stimulation from the environment and the initial encoding of that stimulation into the nervous system. In other words, sensation is our direct physical contact with the world. Perception, on the other hand, is the process of interpreting and understanding sensory information. It involves forming meaningful experience from sensory stimulation. So, for example, the difference between the two could be found in hearing a buzzing sound versus recognizing it as a bee, or in seeing a large black furry mass versus recognizing it as a dog. It's not truly possible to say when sensation stops and perception begins, but you can see that sensation involves the initial introduction of raw information from the world, and perception involves the secondary interpretation of that information. But I think we really take for granted what a role perception or that interpretation of what is out there in the world really plays in our experience. We think that what we see, for example, is what is really out there without giving the perceptual interpretation our brain makes much credit. I have a personal example of this. Once I was at home in my kitchen and I opened up the lid to the trash can. Immediately, when I looked down into the can, I saw little maggots squirming all around all over the trash. After a moment of staring into the can in disbelief, I started to realize that rather than maggots, what I was looking at were grains of rice that I had tossed earlier. It's interesting, however, that what my brain saw was maggots, not rice. I even perceived them to be moving when there was no movement happening. There had been an error in my perception in that case, but what it goes to show is that our brains are responsible not only for the errors in our perception, but also in the interpretation of what we correctly perceive. Hopefully, throughout this course, that will become more apparent. It is really truly amazing what our perceptual systems are capable of, as demonstrated in this figure here. So here we have what is referred to as the distal stimulus, or the object or thing out in the world that we are going to sense and perceive. In vision, the distal stimulus is the object in the environment illuminated by a light source. The proximal stimulus is the light that stimulates our visual receptors. Vision begins by light reflecting off of the surface of an object and shining into our eyes. So the proximal stimulus is the image on the retina, which contains the visual receptors in the back of the eye. Finally, perception is the mental event or experience we have of that object. What is amazing is the multiple hurdles our perceptual system has to overcome in order to properly see the stimulus. One of those hurdles is the fact that as light enters the eye, the image becomes inverted and switched from left to right. Also, not only is that proximal stimulus now inverted and flipped, but it also has taken on a 2D form. However, in the end, we perceive a 3D correctly oriented object. Other hurdles include correctly perceiving the size and the shape of the object. The size of the image on the retina, the proximal stimulus, changes with the distance of the object from us. The shape of the proximal stimulus is going to vary depending upon its orientation. However, our perception of the object matches the correct size and shape of that distal stimulus. So our perceptual system is truly amazing because somehow it has managed to result in the perception of an object's properties that is more similar to the distal stimulus, which is out there in the world, than to the proximal stimulus, which makes up the information it has received. Next, we will get into exactly what light is and how it becomes the proximal stimulus that we perceive.